Welcome, Karl. So what I'll do to get our panelists going is I'm going to ask, you already have heard from Justin, so you kind of know who he is. I'll ask Miguel to introduce himself. And then I don't know if everybody was in Karl's other talks, so I'll ask Karl to introduce himself. Go on, Miguel. Hear me? Yeah.
All right, perfect. So my name is Miguel Ortiz. I'm a solution architect for the IBM Blockchain Labs group. You probably heard Bertrand earlier on the day. I'm a peer of Bertrand, working with client-facing, so working with customers on how to implement blockchain on a number of different use cases, mainly permission blockchain, as well as identity use cases. So think Hyperledger Indy and Hyperledger Fabric.
Great. And Karl, if you want to quickly introduce yourself to this group. I think everybody knows you, but let's...
Fair enough. Yeah, so I'm Karl Kreder. I work for a company called Grid Plus in town. We're a world's first blockchain-based electric utility. If you live outside of Austin, you can buy your energy using cryptocurrency. I also gave a talk today on the Phonon network, which is a layer 2 scaling solution that we're working on. And I'm also involved, or came up with BlockReduce, which Sriram will be presenting later today, which is a layer 1 scaling solution. But the common theme there is I believe that blockchains, specifically public blockchains that are used to settle value, are revolutionary and are going to be massively beneficial to society.
I think we've just set ourselves up for a very good discussion. Miguel works on permissioned blockchains. Karl believes in the public blockchain, and Justin believes Bitcoin is everything. So Karl, since you have the microphone, I'll ask you the first question, and then I'll ask the same question to everyone else. Could you describe for our audience the characteristics of use cases that make them good for blockchain?
Yeah, so the thing that...
Make sure there's a black screen.
Hello? Hello? I can speak up there. Oh, there you go. Hello? There we go. Okay, so the thing that I think makes blockchain, and if you want to extend it, cryptocurrencies revolutionary, is that every information technology up until now, or up until 10 years ago, had to do with the facilitation of the transfer of data. So we had protocols developed like TCP/IP, and if you look at that stack, right, up in the sort of the application layers, they call it, there's things like HTTP, FTP, SMTP, and those are protocols that everybody uses every day to transfer information. Blockchain is a similar protocol that kind of would sit in that application layer, but the thing that makes it fundamentally different than anything else is that it enables the transfer of value digitally, instantaneously, and without intermediaries. So when you ask me what is a good use for blockchain, it is a use that involves the transfer of value between two economically different parties. There are potentially very niche applications where permission blockchains or something like a proof of authority or proof of stake system may make sense, but when it comes to the 95% value proposition of a blockchain, it has to be proof of work, and it has to be a value transfer.
Great, thank you. So Miguel, same question for you. What do you look for characteristics when you want to do, when you feel it's a good use case for blockchain?
Well, the answer to that, I wouldn't be a good solution architect if I wouldn't say it depends. But one thing I want to mention is that a permission blockchain doesn't really mean that it's not public. You can have a public permission blockchain. The idea of permission, it's more that you have an identification of who the parties within the blockchain is. The biggest thing that we looked at, or the biggest factor that we looked at when trying to work with a customer and identifying a blockchain is a good blockchain use case is the network. Understanding who are the different parties that will be part of the network and what's the benefit for them to be in that network. So mutual benefit for the different parties involved, mutual also enough value, each one of them gets enough value to be able to invest in the network. So those are some of the things that we talk to when customers come to us, and sometimes the use cases are actually pretty good. But then we start peeling back the layers and we try to understand, okay, so who else would be part of this? Or are you looking to build it and they'll come type use case, which in most cases doesn't really pan out. So there has to be, we can talk a little bit more about that, but there has to be some sort of mutual benefit to joining that network to begin with. And to his point, yeah, we don't trade in most permission or most of the, not all, but most of the projects that I do is not about trading currency, but think about trading data and data value. That's more the use cases that we deal with in a day-to-day basis.
Thank you, Miguel. Could you, Justin, same question for you.
I agree with the first point of view almost entirely, with one exception. I don't think that if the value is something physical, I think that the blockchain isn't able to enforce its claims, and it will just be ignored. So it doesn't really apply in almost every use case because it just becomes sort of like a parallel reality that isn't respected by the actual the real authorities, which are like the government in most cases. And I think there's one other application. This blockchain as a technology. There's one other beautiful application of blockchain as a marketing campaign. So this is my theory of why there are so many blockchain projects. I think you oftentimes have a large company that has very bad internal coordination. You have a marketing or an engineering manager who wants to upgrade their internal infrastructure. They can't get buy-in from their bosses, and so they say, hey, I'm going to use a blockchain for this. We can go on conferences and talk about how forward-looking we are. We can do TV commercials. They are able to get buy-in for their database upgrade by appealing to sort of marketing interests of the company. And they hire a company to help them do that, and everyone wins. The engineer gets their database upgrade, the boss gets to go at conferences and look cool, get a promotion, and the company that facilitates this whole charade makes a bunch of money. No project is ever delivered at the end. I think that's a phenomenal use case for all parties involved, but I don't want to engage in it.
Come on, Justin, that use case is as old as me. I mean, I already used that when we did the year 2000 remediation, so you can't use that again. So anyway, okay, so my question now, next question for you, and I'll start with you, Justin, and then go to everyone. Can you tell the audience one specific interesting use case that you might be currently working on?
I want to help people cross borders with obscene amounts of money and be able to keep that property that they earned through their hard work and prevent the immoral confiscation of that wealth that they earned. And that's the problem I really want to work on.
So Miguel, if rather, instead of what you'd like to work on, what I'm trying to get at is a use case you might be working on, the most interesting to you today.
Sure. So I'm working in a number of different use cases at any given time. Some of them are pilot use cases. Some of them are more mature and going into production. Some of them are, for example, I can't talk a lot on detail, but I can provide some of the use cases. So for example, one of them is working with a big, and I say this one is interesting because I didn't even think it was going to be that interesting, but it's basically a big sod manufacturer here in the United States in which they actually do experimental seeds for growing grass, sod. What they're looking to do is understand the lineage or the provenance of that grass, especially during the research period. So growing the grass in a farm field, being able to install that grass in a particular garden, and being able to do monitoring of that grass in an ongoing basis, and then track that back to see where were the differences in the different instances of the installation, to be able to do research on it and be able to push it forward. And then chemically, that's probably not a word, but chemically, modify that seed in order to be optimized for the different areas in which they tested or they planted. So they're testing blockchain in order to have the provenance of the seed, similar to what it's been done with, I think in the other room they were talking about hemp and CBD tracking or lineage. We also working in a project in Canada, actually, that's more mature and it's in a more advanced state for production, which is similar to that. In a very different world, working with financial services companies in order to do tracking. It's not payment related, but it's reconciliation related. So someone I think mentioned earlier today the idea of EDI and the changes of EDI. One of the things with EDI today is that, yeah, it's a standard, but it's a standard that the great thing about the standard is that it's very easily to customize. So everyone who has an EDI process probably has a very specific or customized EDI process. And if you have EDI processes with a number of different customers or different entities, you'll have to deal with a huge overhead of reconciliating with each individual entity that you do business with or do transactioning with. So those are also part of the project that I'm doing, which is how do we not only understand the EDI, but move the reconciliation process to a smart contract algorithm, right? And that makes it so you can build it once and deploy it and use it with all your different entities, as opposed to what it's done today, which is customized process for almost all the entities that you do business with.
Thank you, Miguel. Karl, same question for you.
Yeah, so when I heard Justin give his response, I had to contain myself to not jump up and go give him a hug. That being said, I think there's one point where we potentially differ, and that point is that I don't believe that the current state of the art is sufficient in long term to enable what Justin wants. So what I'm focused on is what I think are the two biggest problems with blockchains. The first is usability. So at Grid Plus, right, we've built the Lattice 1, which is a simple to use interface that is secure, etc. And part of that is a safeguard, which manifests a blockchain in something that looks and functions almost exactly like a debit card, which everybody in the world knows how to use, right? So to make these things work, we have to have usability, and without usability, we can't get mass adoption. Without mass adoption, Justin's dream is not sustainable. The second thing is scalability, right? Currently, because we don't have a super large number of use cases and enterprise use cases on public blockchains, we have kind of skated along with this low level of scalability. But the sort of issues that scalability problem makes in terms of how you solve that, and potentially the centralization that comes from solving that, right, is a threat to the original concept of the decentralization that Bitcoin promised. So the things that I'm focused on, usability, scalability via Phonon, as well as block reduce, Shriram will speak about that later, in terms of a specific application use case, value transfer in the form of instantaneous settlements, with Grid Plus for electricity. The reason that electricity is so interesting is because it represents a real-time commodity. If I have a real-time commodity, but I have a non-real-time payment system, there's a disconnect of both capital and credit, and potentially the intermediaries that facilitate that exchange of capital and credit that has to take place in that economic transaction, which are just completely zero value add. So if we can create the systems to have these real-time commodities be reflected with a real-time settlement, we can make those markets more efficient. Other examples of those markets would be bandwidth, right? Bandwidth is another example of a real-time commodity. Telecommunications. So I think all of those are really ripe use cases beyond the one of opting out of the default monetary policy and system.
Great, thank you, Karl. Miguel, this one's for you. Going back to the SOD use case that you described, I think it might be helpful for everyone to understand why a distributed database could not have solved the problem, or what are the barriers in solving that problem with using a distributed database or a database that all the parties can write to?
Yep, that's a great question. And in every use case that, or every customer engagement that we go to, that's one of the questions, okay? And actually, so before I answer that, you mind if I do a quick overview of how we engage in some of these?
Yeah, please.
So when we go to a customer, our first interaction with the customer, it's understanding what they want, right? In some cases, they actually have a very good idea of what they want to do. They definitely know their business, in most cases. They definitely know their business, but what they want to do with blockchain may or may not be possible or feasible or even make sense from an ROI perspective, right? So some of the things that we do is understand what their business is, understand what their use case is, how they want to use blockchain, and all these questions basically of, you know, do you want to use a database? Why wouldn't you just use a regular database and all that stuff? All that is questioned back to them. Sometimes we come up with solutions that are not blockchain, which is fine, and my group can handle that as well. Sometimes it's a matter of the network is not ready to be part of this, so it may not make sense to make it a blockchain solution at the moment. And sometimes it makes sense, right? So in the case of the SOT aspect, what's the amount of parties that were involved? For example, they have a number of different huge departments internally to begin with. So those were parties that were involved that wanted to have conversations. So I don't know how many of you have been involved in, for example, financial services before, but if you're in a bank, in a big bank, their own departments don't talk to each other. Their own departments don't share data with each other. And their own departments have huge governance initiatives in order to figure out who owns what and what I'm not going to share with you, with the other groups. So imagine if that's internal for a big bank. Imagine how hard it is to get a big bank to actually talk to a different big bank, right? To share data. And that's the same in a lot of big companies, guys. So same thing in IBM. I'm an IBMer, and it's the same thing internally. So in this particular case, they had an issue which was, how do we share data internally between the different parties, but then how do we actually get external parties, for example, their contractors, their farmers, their installers, their, I forget what the name of they're basically contractors, but their brand, they are signed in order to basically sell the seats for them, so, but they're not part of the big company. So all these guys are multi-million-dollar companies also involved, and they're all trying to gather data around it. And in some cases, it wasn't feasible either to gather the data, or it wasn't a good investment for some of the contractors to actually share the data back with the mothership, right, with the main company that they were doing business with, because they also had other SOD manufacturers that they did business with. So what the goal was is how can we share data across, protect some of the data, and then make some other accessible to the parties that needed it. For example, we want research to have data in order to optimize the product that you make, but we probably do not want your marketing team that pushes out basically information to the competitors, to the contractor competitors. So there was a lot of politics involved in the process in order to get that data sharing happening. And that was, when we talk about a blockchain solution, yeah, the technology is part of it, but the technology is only 20% of the whole solution that we need to put together, putting together the governance layer, the business layer, and making it feasible and valuable for the whole network. It's a bigger challenge, especially the legal aspects of it. And you can see that if you see parts of the blockchain solutions that IBM is sponsoring. For example, the food trust solution that was mentioned earlier this morning, or TradeLens, which does open ocean cargo. Those type of solutions, yeah, they're basic when it comes to, explaining the solution is not hard. Everyone knows that could be an easy technological thing to do. The really hard part is actually working through the legal issues that all these parties come together, that happen when all these parties come together, right? So you have international customs field groups. You have large container companies. You have insurance companies. You have the different parties that work in the ship area for packaging and actually loading the truck. All those are independent companies that come together, and now we have to figure out how they're all going to play in this particular use case, how all they play today, and how can we make it easier for them to be onboarded into the blockchain solution.
I have a follow-up to that. So in your example of the SOD company, can you articulate why, in that case, I couldn't have used a database, maybe an event source database, that had, some permissioning and credentialing against who could see, modify, and write fields instead of a blockchain? Like, why did you have to use a blockchain?
Yep. So, look, I think the answer, it's always the same, right? So if you can, if every party in a possible situation agree, and someone to hold the database and cater the database and actually manage it, and you're going to give them your data and they're going to govern it for you, then we wouldn't be talking about blockchain, right? And that's usually the situation that happens. Blockchain is not just a database or a distributed database, at least for us, right? The way we see blockchain, and this is not crypto, right, or currency, we're not talking about that part, but the way we see blockchain is in a number of different technologies that you use already today, sandwich into one. For example, if you are using blockchain, yes, you're using databases. Yes, you probably have some sort of, you need a rules engine at some point or another in order to make sure you implement business rules. As part of the solution, you probably have an enterprise bus or some queue or some, and you can continue to stack the amount of technologies that you need in order to implement the same solution that you would have implemented in blockchain with theoretically one technology, right? So those are some of the things that we're looking at for this particular use case. In the case specific to the SOD company, they wanted to have the external companies be able to share the information together with the big company, right? With the main company sponsoring the project, but still have the capability to manage and own their data, so they can regulate who's looking at their data and when they can share and when they cannot share the information. Who can see their data and when. So they wanted to be able to throttle the amount of access to it. So, for example, the time of the month or the month, for this quarter you can see this data. After that, it kind of goes away from your vision. So they wanted to do something like that. And one of the things that happens is, like, if you're doing it point to point, that's easy, right? You have your APIs, I have my APIs, I connect your APIs to you. But if I'm doing that with 20 other different companies or more in their case, now I have to modify APIs with every single person or every single entity that I'm having to do this integration with. And if someone decides to change their API format, now you have to go back to the drawing board and kind of do modifications. So the idea is, if we're gonna put this in place, instead of doing it point to point, how can we do it? From what other options do we have? And that's how blockchain came into the conversation.
Yeah, great, thank you. So I'm going to follow this up, Justin, with a question for you. And I'll go back to your story about we should just use this for marketing and getting budget. When you find a client who is doing that, how do you usually advise them? And how do you decide whether their application is really for blockchain or not?
Well, I don't really come across this problem. I'm not a marketer. I'm interested in building, improving money as an engineer. So I don't come across this problem. But if they were doing it, I would probably, it seems like it works for them in their weird use case. And if they want to keep doing it, it works for them. It just doesn't seem like it relates to blockchains, or it doesn't seem like it's remotely related to what I do. So I think it's more of a marketing ploy, and I don't really understand it.
Okay. So Karl, in your case, when you talk to people and they're trying to do something that you believe is not blockchain related, how do you A, decide that, and B, how do you advise them?
Yeah, so, right, so when I was at Consensus, right, you'd have a lot of conversations with a lot of people, and a lot of them were, falling into this marketing or raising money or something using the concept of a blockchain. And the way I approached it is, again, I fundamentally think that blockchains involve value transfers between disparate economic parties, and anything else besides that can be manifest in a database. So I would first try to tease out what they were trying to accomplish, who the parties were, how their interests were separate, and what sort of value needed to be transferred between the two. And there are potentially some very complicated use cases for that. It's not just money, right? You can use a blockchain to transfer a stock contract. That is a great use case. You can use a blockchain to transfer money against a legal contract. Now, Justin may disagree with that, but although it can't be enforced on a blockchain, we still do live in the realm of nation states, and we live in the realm of courts. So just because the blockchain can't enforce the rules doesn't mean that I don't have other mechanisms by which those rules can be enforced. So those are perfectly valid use cases, in my opinion. If somebody came to me with a data use case, there are some data use cases that are potentially compatible with a blockchain, and the one that I think is somewhat universal is the concept of proof of existence or notarization. So you don't actually need a blockchain for that outside of Bitcoin, because I can take a set of data, I can hash into a Merkle root, and then I can record that hash onto the Bitcoin blockchain so that a year from now, if I want to prove to you that I had a document or I had 1 million documents, as long as I could show that it's part of that Merkle tree, I can prove that that document existed at that point in time and that there was no way that I could sort of surreptitiously add it at some point in the future. So that's kind of like a great data use case. But when it comes to interoperating between companies and sort of this concept of standardization, there's no difference between saying, hey, we're going to have to get all these companies to agree on an API to, hey, we're going to have to get all these companies to agree to use Hyperledger. It's the exact same thing. It's just in one case, you're saying it's an API to a standard database, and the other one you're saying, hey man, it's blockchain, right? The rules engine that you can put on the blockchain is the same rules engine that you can put above a database in terms of distributed database and who manages that data, right? You can permission, you know, what silo of data is within what company, and then what participants in that system can see what data, what participants can write what data, and all of that can be done completely independently of a blockchain. Now you could argue that, right, you stack all these things together and that creates a blockchain. In my mind, the only thing that creates a blockchain is a consensus mechanism. A blockchain is a data structure. The thing that's valuable here is a data structure plus a consensus mechanism. When we're talking about a value transfer, the consensus mechanism that I think is the only one that's been shown to work is proof of work. That's an economic consensus mechanism. That's how we get value transfer. There's other consensus mechanisms that are potentially valuable for other situations. Proof of stake is what I would call social consensus. Proof of authority is kind of like the Federal Reserve. So, I mean, right, it depends on the use case, but blockchains do have use cases. Most of them are value, some of them are not. And if somebody comes to me and says, hey, you know, I want to do it for this, that, or the other, I'll say, hey man, Apache Kafka, have fun.
So I would do a decision diagram, and this is, I'm borrowing it. It's like, are you making money? Yes, use Bitcoin, the only blockchain that works. No, don't use a blockchain. From Safety and Amos's Bitcoin standard.
I love simple decision trees. So I have time for one question to the panel from the audience. Yes, please.
Well, I was talking about proof of work, right? But one of the biggest feedbacks is that it takes a lot of energy. If there's an, for something to actually get into a kind of complete consensus in Bitcoin takes a long time, right? So what's your answer for that?
So if you've ever gone skeet shooting, there's what you call the beer skeet. So when they throw it out from the tower straight ahead of you, it's the easiest skeet to hit. So you just threw the beer skeet up, because if you miss that skeet, you got to buy everybody beer. Anyway, the answer to the energy thing is you have to compare the context, right? From 2000 to 2008, 30% of the US GDP was attributed to financial services. Blockchains can disrupt the vast majority of financial services. So if we spend 1% of the world's GDP to replace 30%, who cares? I have made the world 30% or 30 times more efficient than it previously was. It is a problem of energy, but the only way that I've ever seen of enforcing security is by the verifiable destruction of an asset. And every asset will ultimately trace itself back to energy. So if that asset is, provable storage, if that asset is proof. Hello? That asset is proof of work. It all varies back down to the same thing. It's just energy. So if we want these distributed systems where we don't have to trust intermediaries and we're going to do it with a consensus mechanism, it's always going to come back to energy. It's always going to come back to work.
Can I add one more thing?
Yeah, one last thing.
Okay, it's working again. So one thing in permission blockchain, again, this is not the same, right? So, but in permission blockchain, usually we could do proofs, but we usually don't. In most cases, we don't. We try to do basically what comes down to the equivalent of business rules, right? That's where the smart contracts come in. And more you see us working with legal parties. So the lawyers that figure out the contracting. And the reason they are involved in our processes is to understand how they can transfer their legal contracts. You know, smart contract is not a legal contract. It's just, at the end of the day, it's chain code. It's code, right? But what they're trying to understand is, from a legal perspective, how they can implement those legal contracts and make them automatically deploy within the blockchain itself. So when we're transacting, we are actually transacting and legally abiding by the contracts that we have in mind. And the problem is that, to his point, is that usually you have different contracts with different entities, and you do not want to replicate the contracts with all the different entities. So you can have different implementations, and your transaction, although seemingly the same, it actually acts differently with all the different parties that you're transacting with. Also, to the point of the technology stack, yeah, you can actually replicate all of that in outside of blockchain, which is fine using the whole technology stack. But at the end of the day, it's not only the cost of the technology stack that you have to deal with, it's the people to maintain it, and then the maintenance of that stack when it comes to the length of actually having it and upgrades and all of that comes with it. So if you have 10 pieces to the stack as opposed to, 4, you're saving millions of, the companies that I deal with are saving millions of dollars in a long term, right? So those are some of the things that we look into when it's the business value aspect of making a solution with blockchain.
Great. So please join me in thanking Justin, Manuel, and Karl for such an enlightening discussion.
Miguel, but thank you.
Miguel.